So good day everyone. Today I will discuss about permutation with repetition, permutation without repetition, and combination with repetition and combination without repetition. So first, permutation with repetition is a concept of combinatorial mathematics that deals with arranging objects, and some of them are identical. It is often used in situations where we need to find a number of possible arrangements of objects or elements with repetitions allowed. To understand this permutation with repetition, let's consider a simple example. Suppose we have a set of objects with distinctly, let's say A, B, and C. A, B, and C. We want to find the number of possible arrangement when we can repeat these objects. Let's start with a specific scenario where we want to arrange these objects in sets of two. The possible arrangements with repetition allowed would be A, B, AC, BA, BB, BC, CA, and CB, and also CC. As you can see, each object can be repeated in the order matters. To determine the total number of arrangements, in this case, we use the formula for permutation with repetition, which is given by n raised to r, n raised to r. So where n represents the number of distinct objects or elements available. In this case, 3, A, B, and C. R represents the number of positions or slots to fill in this case. Applying the formula, we have 3 raised to 2. 3 raised to 2, which equals to 9. Equal to 9. Therefore, there are 9 possible arrangements when selecting two objects from a set of 3 repetition allowed. So it becomes 3 raised to 2 is equal to 9 because we will only repeat 3. So 3 times 3 is equal to 9. This concept can be extended to situations with more objects or different values of R. For example, we had 3 objects, A, B, and C, and wanted to arrange them in sets of 3. We would have 3 raised to 3. So the number of repetition or possible arrangement of this would be 27 plus 3 times 3, 9, 9 times 3, 27. So permutation with repetition is particularly useful in various fields such as probability, statistics, and computer science. It allows us to calculate the number of possible outcomes when repetition is allowed, helping us analyze and solve problems that involve arranging objects or elements in different orders. By understanding permutation with repetition, you will be equipped to handle a wide range of scenarios where repetition is a factor. It is an important concept to grasp and can be applied to many real-world situations. Now let's go forward to permutation without repetition. So permutation without repetition is a concept in combinatorial mathematics that deals with arranging objects or elements when each item is distinct and can only be used once in a particular arrangement. It is often used to determine the number of possible arrangements of objects in a specific order. To understand permutation without repetition, let's consider a simple example. Suppose we have a set of objects with distinct labels such as A, A, B, and C. We want to find the number of possible arrangements when each object can only be used once. Let's start with a specific scenario where we want to arrange these objects in a set of 2. The possible arrangements without repetition allowed would be AB, AC, BA, BC, CA, and CB. As you can see, each object can only be used once in each arrangement and the order matters. To determine the total number of arrangements, in this case, we use the formula permutation without repetition, which is given by n factorial. n factorial. n factorial, where n represents the number of distinct objects or elements available. In this case, 3, A, B, and C. Applying the formula, we have 3 factorial. 3 factorial. Which equals to 3 times 2 times 1. 3 times 2 times 1 is equal to 6. Therefore, there are 6 possible arrangements when selecting two objects from a set of 3 without repetition. This concept can be extended to situations with more objects or different values of R, which represent the number of positions or slots to fill. For example, if we had 4 objects, A, B, C, and D, and wanted to arrange them in a set of 3, we would have 4 factorial, which equals 4 times 3 times 2 times 1. So there are 24 possible arrangements of this. So permutation without repetition is a fundamental concept in combinatorial mathematics and has applications in various fields, including probability, statistics, and computer science. It allows us to calculate the number of distinct ways to arrange objects in a specific order, ensuring that each object is only used by once. By understanding permutation without repetition, you will be able to analyze and solve problems that involve arranging objects or elements without repetition. It is an essential concept to grasp and can be applied to a wide range of real-world scenarios. So now let's move on to combination with repetition. So combination with repetition is a concept in combinatorial mathematics that deals with selecting objects or elements from a set, allowing for repetition of the chosen items. It is often used to determine the number of possible combinations when selecting objects without regard to their order and allowing for the same object to be chosen multiple times. To understand combination with repetition, let's consider a simple example. Suppose we have a set of objects with distinct labels, such as A, B, and C. A, B, and C. And we want to select two objects from this set allowing for repetition. The possible combinations with repetition allowed would be AA, AB, AC, BB, BC, and CC. As you can see, each object can be chosen multiple times and the order of the objects in a combination does not matter. To determine the total number of combinations in this case, we use the formula for combination with repetition, which is given by n plus r minus 1 c r, where n represents the number of distinct objects or elements available. In this case, 3, A, B, and C, and R represents the number of objects to be selected, in this case 2. Applying the formula, we have 3 plus 2, 3 plus 2, minus 1, C2, C2, which simplifies for C2, for C2. Using the combination formula, we calculate for C2 as so 4 factorial 4 factorial divided by 2 factorial times 4 minus 2 factorial, which equals to 4 times 2. So this equals to 4 times 3, 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1 times 1. So this is equal to 6. Therefore, there are 6 possible combinations when selecting two objects from a set of 3 with repetition. This concept can be extended to situations with more objects or different values of R. For example, if we had 4 objects A, B, C, and D, and wanted to select 3 objects, allowing for repetition, we would calculate 5C3, so that would be equal to 10 possible combinations. So combinations with repetition is useful in various fields such as probability, statistics, optimization problems. It allows us to calculate the number of possible combinations when repetition is allowed, helping us analyze and solve problems that involve selecting objects without regard to their order. So by understanding combination with repetition, you will be equipped to handle scenarios where repetition is a factor in selecting objects. It is an important concept to grasp and can be applied to many real-world situations. So now let's move on to combination without repetition. So combination without repetition is a concept of combinatorial mathematics that deals with selecting a subset of objects or elements from a larger set, where each element can only be chosen once, and the order of selection does not matter. It is often used to determine the number of possible combinations when we want to select a specific number of items from a set without repetition. So to understand combination without repetition, let's consider a simple example. Suppose we have a set of objects with distinct labels such as A, B, and C. We want to find the number of possible combinations when selecting two objects without repetition. So the possible outcomes or combinations without repetition would be AB, AC, and BC. As you can see, each object can only be selected once, and the order of selection does not matter. In other words, AB and BA are considered the same combination. So to determine the total number of combinations in this case, we use the formula for combination without repetition, which is given by N C R is equal to N factorial divided by R factorial N minus R factorial. So where N represents the number of distinct objects or elements available. In this case, A, B, and C, and R represents the number of items to be selected in this case. Applying the formula, we have 3C2, 3C2, which equals to 3. So this equals to 3 factorial divided by 2 factorial, 3 minus 2 factorial, resulting in 3 possible combinations. So the result of this will be 3 possible combinations. So this concept can be extended to situations with more objects or different values of R. For example, if we had 4 objects, A, B, C, and D, and wanted to select 3 objects without repetition, we would have 4C3 is equal to 4 factorial divided by 3 factorial times 4 minus 3 factorial. So that would be equal to 4 possible combinations. So combination without Repetition is widely used in various fields, including probability, statistics, and combinatorics. It allows us to calculate the number of distinct ways to choose a subset of objects from a larger set, ensuring that each object is selected only once and the order of selection is not considered. By understanding combination without repetition, you'll be able to analyze and solve problems that involve selecting combinations from a set without repetition. It is an essential concept to grasp and can be applied to a wide range of real-world solutions. That would be all. Thank you.